Okay, so here we're reading this problem. We've got a list of possible roots for the given in the tables below here. Okay, and there's two different sets here. You'll notice that the first set clearly look like angles from 0 to 2 pi, and the second set here are overall whole real numbers here. So let's take a look at the question. It says the roots of the equation 4 sine squared minus 3 equals 0 on the domain 0, there it is, 0 to pi, are blank, and then on the domain x is an element of the reals are what? Okay, so we got to take a look at this. 4 sine squared of x minus 3 is equal to 0. Okay, so we'll just write it up here. 4 sine squared of x minus 3 is equal to 0. So 4 sine squared of x is equal to 3. Sine squared of x is equal to 3/4. And hopefully you're familiar enough with the unit circle, you can kind of see where this is going. If I take the square root now of both sides, whoops, sorry, just said I was going to take the square root. Here we go. I will get positive negative the square root of 3 over 4. Now, I'm not going to do much with the square root of 3, but the square root of 4 is 2. So I'm asking, where does sine around the unit circle become root 3 over 2? And my reference angle, and I typically use the variable alpha for the reference angle here, is going to be pi over 3. That's going to be the smallest angle between any terminal arm that satisfies this equation and the x-axis here. So that means I am chopping up the top half of the circle into 3 and the bottom half of the circle into 3. That is what the pi is right here. Pi over 3 means I'm chopping up half of the circle into thirds. And so now what I've got here is I've got this angle, which is pi over 3. This would be 2 pi over 3s, 4 pi over 3s, and then all the way down here is 5 pi over 3s. And so we can see right there that the answer there has got to be 3. Now, in general, what would this look like? Well, first of all, we know that our reference angle is going to be pi over 3, so it's none of those. It's got to be 7, 8, or 9 here. Now, let's just take a look at what's going on here. What happens is we've got a nice little bit of repetition with these angles here. This angle right here, if I add 180 to it, and add pi to it, 180 degrees or pi radians, I will get the other angle. Okay. And that just happens to be just a little bit of the result of the symmetry of the problem here. If I take this angle right here and add pi to it, I'm going to get this angle down there. So really what I need are the two angles, pi over 3 and 2 pi over 3. And then I can expand on that by adding pi. So now that's what I'm looking for here. So I'm looking for pi over 3 plus multiples of pi, 2 pi over 3 plus multiples of pi, and that is 7. Now, just to make sure that you understand why this works the way it does, or why that's the answer and why the other ones aren't, take a look at 8. What 8 is doing is starting at pi over 3 and adding pi over 2, multiples of pi over 2. Now, there is a form of this kind of a question where that does work, but only when the reference angle is pi over 4 or 45 degrees, because it assumes that the difference between these things is 90. In this case, it's not. It's 60 degrees. Okay, so the difference between those is 60 degrees, 60 degrees, 60 degrees. And so I'm not continually adding pi over 2. And then the problem with 9 is that it's starting at pi over 3, but it's adding full rotations, not half rotations. So it's only catching the angles that are in the quadrants 1 and 2, or the top half of the unit circle. So the answer here has got to be 3, and then over here this will be 7.